Next, we are going to discuss about alkenes, a new homologous series. Last time we discussed about alkanes and alkanes which have carbon-carbon single bond. And now, next homologous series that is alkene. Now, what's the difference in their names? First of all, look at this. The ending name of alkane that was ANE, and the ending name of alkene that is ENE. So, in this homologous series alkene, if we talk about the difference, so the functional group of alkane that was carbon-carbon single bond. But here the functional group of alkene is carbon-carbon double bond. Clear? So this double bond is a functional group of this new series. So let's take one example. If we talk about this member of alkane series in which all the carbons they have single bond with each other. So remember that we named these type of compounds in which every carbon that is making four single bonds, we called them saturated. So alkane is a series which contain all the compounds and they are known as saturated compounds because of carbon-carbon single bonds. But when we talk about the first member of this series having the carbon-carbon double bond, so how many hydrogens? We need two hydrogen atoms with every carbon atom to make the four bonds of each carbon. So you can see if I number this carbon as carbon 1, this carbon as carbon 2. So the carbon 1 is making 1, 2, 3, and 4 bonds. And carbon 2 also making 1, 2, 3, and 4 bonds. But the difference in alkane and alkene, what we can see here, that the carbon is not making four single bonds. Clear? So these type of compounds which have carbon-carbon double bond, they are called unsaturated hydrocarbons. So all those compounds, remember, which have carbon-carbon double bond at any point, they are known as unsaturated hydrocarbons. Why we are calling them unsaturated hydrocarbons? Because if any one of the carbon is not making the four single bonds like this, as we saw in saturated hydrocarbons, they are known as unsaturated hydrocarbons. For example, let's take another example. How can we draw them? Look at this. First, draw the chain of carbon atoms. Clear? And then you can place a double bond at any position. Look at this. Here we can see one of the carbon single bond is now the double bond, and the rest are hydrogen atoms. So how many hydrogen atoms? Here two to make the four bonds of this carbon. Here we have one, two, and three bonds already made. So one hydrogen with this second carbon, and this carbon has made two, so two more hydrogens. Okay, this has one, two, three. Okay, so every carbon four bonds, but here we can see there is unsaturated point, which is carbon-carbon double bond. Now, the same compound can be drawn like this. Four carbon atoms. Clear? And I am now placing the double bond at this position. So let's place the hydrogen atoms. So one 2, 3, and 4. 4 bonds of this carbon satisfied. Now, this carbon has already made 1, 2, and 3 bonds. So, one hydrogen here, this carbon 1, 2, and 3, the one here, and this carbon has made only one bond yet. So, 3 hydrogens with this one. Now, if we look at their molecular formulas, remember what do we call this? Actually, it is a displayed formula in which we show each and every bond. And when we want to write its molecular formula, what we have to do, we have to count their number of carbon atoms. So 1, 2, 3, and 4. So there are 4 carbon atoms, and if we count the number of hydrogen atoms, so 1, 2, 3, 4, 5, 6, 7, and 8, C4H8. And now this one, it also has 4 carbon atoms, and 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so these two are having the same molecular formula, but we are observing one thing. What is that? That is the position of the double bond. Remember one thing when we talk about the position of the double bond, what we have to do, we have to number the chain of carbon atoms, right? Okay. This one is also having a double bond. And how do we number the carbon atoms? Remember the double bond, we will start the numbering from the end where double bond is nearest. So here I started the numbering from the right side. Why? Because the number double bond is near on this side. So that's why I started numbering from the right side. But in this case, you can start numbering from any side. Because if you start numbering from the right side, the double bond is at second position. And if you start numbering from this end, 1, 2, and 3, and 4, it will again on second position. So we can do numbering on either side. Is it clear? So these two compounds, they are known as isomers of each other. Why we are calling them isomers of each other? Actually, they have same molecular formula, right? But they have difference in their structure. Same molecular formula, but different structure. Clear? And what difference in their structure we can see here? The difference in structure is the position of double bond, right? Okay, if they have this type of difference, so this type of isomerism is also known as position isomerism. We call it position isomerism. The isomerism which arises due to the difference in the position of the functional group. Remember, what is functional group? Functional group is a double bond or single bond or triple bond or atom or group of atom which gives a characteristic properties to the compounds. They are known as functional groups, right? So here we can see the functional group is double bond. If we change the position of the double bond, then the structures will be different. Now their names will also be different. So after this, let's talk about the naming of these alkenes. So the first member of this alkene series that have at least two carbon atoms. And we can see the name difference, alk and ene. Alk stands for the numbering. So how many carbons here we have? Two. So its name should be ethene or ethene. The second member, double bond here, and how many hydrogen atoms? Uh, Two here, one here, and three here. So it's prop and ene. Okay. Next, four. After four carbon atoms, we can see the different positions where we can place the double bond. So its name is butene. We have four carbon atoms and there is a double bond. So but for the four carbon and double bond ene. And here you can place the hydrogen atoms like this. Okay. Now we also can place the double bond at another position, same compound. Okay, so here we have hydrogen atoms as well. Two here, one here, and three here. Sorry, three here. Okay, now what's the difference between these two? The position of the double bond. So we have to name them differently. Here we have double bond at position between carbon 1 and 2. When we talk about the position, so remember the smallest number will be used to mention the position of a double bond. If it is present between carbon 1 and 2, so its position is 1. So we call it 1 butene. But when we talk about this one, we can see the double bond is between carbon 2 and 3. So it means its position should be the smaller number, 2. So it's 2 butene. Is it clear? So 1 butene or 2 butene. Or we can also name it as but means 4 carbon atoms, then 1 and then ene. But 1 ene means 4 carbon atoms and the double bond ene is at position 1. So this can also be named as but to ene. 4 carbon atoms and the second position where the double bond is. Similarly, we can draw another isomers of 5 carbon atoms or 6 carbon atoms. Now, after the naming of these alkene series, let's talk about their molecular formula. So it's C2H4, it's C3H8, it's C4H10, and similarly C5, sorry, C4H8. C5H. Sorry, here this should be C3H6. So if we look at their molecular formulas, so we can apply this general formula CnH2n. So you can see the number of hydrogen atoms, they are double in number as compared to the number of carbon atoms. So that's why their general formula, that is CnH2n. So next, whenever we talk about the homologous series, where we can say their chemical properties, they are same, but what about their physical properties? As the chain length increase, their physical properties, they also change. But their chemical properties, they remain same. Why? Because they have same type of chemical bonds. Is it clear? Okay. Now, after discussion of this, Isomerism. Which type of isomerism? They show position isomerism, their naming and their structures we can draw like this. Let's talk about their chemical properties, which are very important. So remember the first chemical property, that is combustion, which is same for all hydrocarbons, whether it is an alkane or it is an alkene or any other hydrocarbon. When they react with oxygen, and they will produce carbon dioxide and water and heat along with it. But the most important reactions of these alkenes, which we are going to discuss now, they are their reactions because of the double bond. As we know, we named these hydrocarbons as unsaturated hydrocarbons. What is the meaning of this unsaturated? Why we are using this? Unsaturated means that all the carbon atoms in case of alkenes, they are not completely bonded with four different atoms. Look at this. When we talk about this one, we can see if one of the double bond that is broken down, let's say, let's break this, you can see a vacancy can be created on each carbon atom after the breakdown of one of the bond. So that means all those compounds in which a vacancy can be created, they are known as unsaturated. So it means unsaturation means a vacancy can be created on them by breaking one of the bond. Clear? So as I created a vacancy on each carbon atom after breaking one of the bond. So look at this. If I have this ethene molecule, I am naming it as eth and ene. So one of the bond is broken down, so I will get this compound with one vacancy free. Okay. Now we can add any atom on it. So any, I am writing down atom on these both carbon atoms. So vacancy creation and then addition of another atoms. So which type of reactions? Actually, these reactions are called addition reactions. The atoms can be added on these molecules after the breakdown of the double bond. So now let's practice this reaction. If I treat this same ethene molecule by looking at this example and I react it with hydrogen. So what will happen? One of the bond that will break down like this, right? And vacancy create on ethene molecule. And now these hydrogen atoms, they will add on each carbon atom. After the breakdown of this double bond, we have seen a created vacancy. And now the hydrogen atoms, I am drawing those atoms, newly added atoms on the carbon atoms with a different color. So what we can see in this reaction, this was our ethene molecule. And now after the addition of hydrogen, it has become ethane, isn't it? So all carbon atoms, they are bonded with hydrogens and now it is saturated. So actually, which type of reactions it is? It is addition reaction. So the hydrogens added on each carbon atom. So this reaction is actually carried out in the presence of heat. Remember, the conditions are very important, and pressure, and also the nickel catalyst. So I have given one of the example. Let's take the another example. I'm drawing their structural formula now. CH3, CH double bond, CH2. As we can see, there are three carbon atoms, so it's propene. And if hydrogen molecule added on it, so what will be our product? So you can see the hydrogens will add on both carbon atoms. So we get CH3, CH2 single bond, and CH3. So propane. So unsaturated hydrocarbons after addition of hydrogen converted into saturated hydrocarbons. So remember, same conditions, nickel catalyst, heat and temperature. So the addition of hydrogen to alkenes give us alkane. And the application of this reaction, that is very important. We use this reaction in industry to convert the vegetable oil into margarine, right? So actually vegetable oil, they are unsaturated molecules. So it means there are large number of double bonds in their molecules, and we treat them with hydrogen and we convert them into margarine, which is normally in our Pakistan that is known as ghee. Clear? So that is vegetable oil is actually liquid at room temperature, but margarine that is semi-solid state. So we convert the unsaturated hydrocarbons into saturated hydrocarbons by addition of hydrogen in the presence of nickel catalyst. So the conditions are very important, and the application that is also very important. Now the same type of reaction, let's try the addition of another molecule. Let's say I have ethene double bond and I want to add, let's say, chlorine on it. Hmm. So Cl2. So what happens? As we did in case of hydrogen, same. One of the bond that will break down, and the chlorine molecules, they will add on the carbon atoms. So CH2, one of the bond is broken down, CH2, and a new atoms added on each carbon atom. It's a new compound which is formed by the addition of chlorine. So we call these type of reactions as halogenation. Why? The addition of halogens or the group 7 elements like chlorine, like bromine, like iodine. So here the carbon atom 1 and carbon 2, they have chlorine atoms on them. So it is 1 and 2 dichloroethane. Clear? So it is addition of halogens or chlorine, one of the example, on alkenes, giving us these saturated compounds with halogens on them. And let's see if I treat the same molecule, C double bond C and hydrogen atoms, and I want to add bromine on it. Hmm. Bromine molecule. The same procedure, one of the bond will break, one bromine to this carbon, another bromine to this. So we have these results. Okay. So CH2, CH2, and we are on each carbon atom. So you can see it is now saturated because all carbon is making four single bonds. But remember, this reaction is very important because we can use this reaction for identification test, identification of unsaturated hydrocarbons, right? So we will use this test. Why? Because when we use bromine, which is aqueous bromine, right? So it has a specific color, which is orange. So the color of orange bromine when it reacts with a compound, any compound like ethene, which has a double bond. So after addition, the product which is formed that is colorless. Got it? So identification of unsaturated hydrocarbons, we can use it. For example, if I take any compound and it is a colorless compound and we don't know whether it is saturated or unsaturated. Let's say it's a compound X and we are not aware about this, the nature of this compound. So if we want to identify whether it has a double bond or not, so what we will do, we will add bromine aqueous, which has orange color. If on addition of bromine to the X, if the color of the bromine disappear, then that indicates this compound X is unsaturated, means having a double bond. And if the color of the bromine remains same, orange, that means the given compound X is saturated. It means it doesn't have any double bond. Is it clear? Okay, now look at this. Which two types of addition reactions we have seen? We have seen the addition of halogens, which is known as halogenation. We have seen the addition of hydrogens like this, giving us alkane and their applications as well. Now, let's talk about the same type of addition reaction. Hmm. What if I treat this alkene CH2, CH2, and I treat it with water? Now, again, addition reaction will take place. So the one of the bond that will break, and I have broken down the water molecule into two halves. So one of the hydrogen, one part of the water that goes to one carbon, the another part of water goes to another carbon. And after addition, you will see it will become CH3 because earlier there were three two hydrogen atoms, but now here we have three hydrogen atoms, right? And one of the double bond, when it is broken down, it became single bond, and then it became CH2, and now OH, right? So CH3, CH2, and OH, a new class of compounds that will form, which are known as alcohols. Is it clear? So why we are calling them alcohols? Because these are the compounds which have OH group in them. That is the functional group of alcohols. And the name of this example, that is ethanol. We will discuss about alcohols in our next classes. So ethene, when reacts with water, that gives ethanol. And you can see ethanol is very useful compound. We can use in this ethanol as a substitute of our gasoline, petrol. So in industry, ethanol can be manufactured by this reaction. Remember, this reaction takes place in the presence of a catalyst. which is H3PO4, phosphoric acid, that is used as a catalyst in this reaction. So all these addition reactions, they are showing that the double bond will break down and the molecules will add on each carbon atom because vacancies are created on every carbon atom. And now another very important reaction of these unsaturated hydrocarbons, what is that? Their oxidation reaction. It is very important. It is known as oxidation reaction. We also call it hydroxylation, right? Actually, what we do, we treat these unsaturated hydrocarbons with KMNO4. Remember, KMNO4 is oxidizing agent when we treat this in presence. Remember, KMNO4 is used as acidified KMNO4. Sulfuric acid is also used in this reaction. So KMNO4 when reacts with these alkenes, so what we will observe that each carbon atom which is making double bond will get OH group on it. So I can call it that hydroxylation. Hydroxylation means addition of hydroxyl group. What is actually hydroxyl group? Hydroxyl group is OH group. So OH group will add on every carbon atom making a double bond. So in this reaction, what we will observe, remember, observe what we will see. The KMNO4 has a unique purple color. So if KMNO4 reacts with this alkene and this new product will form, so what is the change which we will observe? The purple color will disappear. Okay. Ethene, that was also colorless, right? So this reaction can also be used as identification test for unsaturated hydrocarbons because the unsaturated hydrocarbons, they are colorless when we treat them with purple KMNO4, so its color disappear. So we can use two identification tests for unsaturated hydrocarbons. One is bromine water, which is orange in color, right? If the color disappear, it is unsaturated hydrocarbon. And the second one, that is their acidified KMNO4. And what we colors, remember the colors are very important. We say acidified KMNO4, it means in presence of sulfuric acid. So it goes from orange to colorless, right? And here it goes from purple to colorless, right? So when we conclude about their chemical properties, which type of reactions they are showing addition reaction and addition of hydrogen, addition of halogens and their applications, and addition of water, giving us alcohols. And next addition or sorry, oxidation reaction of these alkenes, giving us these compounds in which we have OH groups on both the carbon atoms, right? We call them diols because there are two OH groups. One OH group means alcohols. So these are the chemical properties and the introduction of alkanes and isomerism. Which type of isomerism? Position isomerism, because there is different position. Remember, this isomerism will occur in all those compounds which have at least four or more than four carbon atoms. So this is all about alkenes. Any question?
No.
Okay, so next we will discuss about the next homologous series.